Okay, welcome back. And now we're going to do this last section on solving exponential equations. We're going to use what we know about properties of exponents to go ahead and isolate our x. So I have the three steps that we're going to do. We're going to determine the power of the base of our result or of our answer, because what we're going to end up is we're going to end up with x in the exponent with a base equals some number. So the number is the result. So we're going to have to figure out what the power of the base is and what the to get that result. We're going to rewrite the equation so that both sides of the equation have a common base, and then we're going to create a new equation to solve with just the exponents and solve for x. So let me show you what I mean. We're going to start here with this one. 3 to the x equals 81. So we're looking at our base, and our base right here is 81, or 3. And so the question is, can we take 81 and write 81 as a power of 3? Well, we can, can't we? Because we know that 3 times 3 is 9, times 3 is 27, times 3 is 81. So 81 is really, 3 to the x is really 3 to the 4th power. Okay? And then, now that we have the same base, 3 to the x and 3 to the 4th power, we can take our two exponents and make an equation out of them. X equals 4. So therefore, x must equal 4. Okay, so that was all we had to do for that one. That was an easy one. Let's do the next one. 5 to the 9x, 5 to the power of 9x equals 5. 5 to the 9x equals 5. So now we have to find a common base, and you can see that our common base is going to be 5. But we also need to know, we have to write our result, our 5, with an exponent. So what would the exponent be for 5? Well, 5 is really just 5 to the 1st power, isn't it? So now we have 5 to the 9x power is equal to 5 to the 1st power. When we have the same bases, then all we have to do is take our exponents and make them equal to each other. So now we have 9x equals 1. And then we just solve for x. Divide by 9, and we get x equals 1/9. And we could check to see that by replacing the 1/9 in for x. If we said 5 to the 9 times 1/9 power, 9 times 1/9 is really equal to 5 to the 1st power, because 9 times 1/9 is 1, which is equal to 5. So we know that we came up with the right solution for x. Let's do the next one. It's a little bit trickier. So now we have, let me try a different color. 4 to the 8 minus x power equals 1/64. And I'm going to need a little bit of paper. So I'm going to write over here 4 to the 8 minus x equals 1/64. So remember that when we have a value, actually let's just look at our 64 and see if we can turn that into a base of 4 with an exponent, shall we? Let's turn the 64 into 4 to some power. Do you know what it is? 1/64 is really equal to 1 over, let's see, 4 times 4 is 16 times 4 is 64. So it's 4 to the 3rd power, all right? But what if I wanted to write 1/4 to the 3rd power with a negative exponent so that I could have my 4 above the denominator line? What if I wanted to cross the line and change the sign? Well, 1/4 to the 3rd power is really equal to 4 to the negative 3rd power. Remember, that was our discussion about negative exponents. So now I have, let's go back, we have our 1/64 we're going to replace with 4 to the negative 3rd power. So I have 4 over 8 minus x equals 4 to the negative third power. Notice now I have two bases that are exactly the same, and all I have to do is take my exponents and make them equal to each other. All right, so I'm going to write 8 minus x is equal to negative 3, and I'm going to solve for x. I'm going to subtract 8 from both sides, and I get negative x equals negative 11. Multiply both sides by negative 1, and I get x equals 11. So I solved for x, and I found that x equals 11. And let's see if we could go back and do this. If we plugged 11 in for x, 8 minus 11 would be negative 3. 4 to the negative third power is the same as 1 over 4 to the third power, and 4 to the third power is 64. So it works. Let's try this next one. 1 over 3 to the x plus 5 power equals 243. So the first thing that I think I want to do is I want to go ahead and get my 3 to the x plus 5 above the denominator line. So I'm going to work up here, and I'm going to say 1 over 3 to the x plus 5. If I cross the line and change the sign, then this would be 3 to the negative x plus 5. Do you see what I just did? I changed the sign, the exponent sign, from a positive to a negative. Now this is a negative x plus 5, so I need to actually distribute that negative sign through both of them, minus x minus 5, and that's going to be equal to 243. Now the only other thing I have to figure out is if I can take 243 and turn it into 3 to the power of something. Now I already know that 3 to the fourth power is 81. What happens if I multiply 81 times 3? Aha, I get 243. So that must mean that 3 times 3 times 3 times 3 times 3 is 243. So I can say that 3 to the negative x minus 5 is equal to 3 to the fifth power. Now I have, my bases are the same. They're both 3, so all I have to do is take my exponents and make them be equal to each other. So now I have negative x minus 5 is equal to 5. I solve for x, and I get negative x equals 10. Multiply both sides by negative 1, and I get x equals negative 10. I can check it by putting in negative 10 for x. And if I say negative 10 for x, negative 10 plus 5 is a negative 5. 3 to the negative 5, 1 over 3 to the negative 5. Cross the line, change the sign. It becomes 3 to the positive 5, 3 to the fifth power. If I put that in my calculator and multiply 3 times 3 times 3 times 3 times 3, I get 243, and voila, it works. So there are 3 different ways that you can solve exponential equations. So remember, when you're creating a table, you're going to look for the geometric sequence, and sometimes you have to use all 3, okay? But you're going to look for a geometric sequence to be able to create your exponential function. When you are using a graphing calculator, you need to have a function that you can graph. So you have to graph your original function, and then you look for the intersection of that function plus a horizontal line, which will represent either the x or the y value, and then you can look for that point, which will tell you what your missing point is. And then if you just want to use properties of exponents, you get your two bases the same so that you can create a new equation with the exponents and just solve for x that way. So that's how we solve exponential equations, and I want you to make sure that you write your key idea here. It could be many different things. It could be any of these three things that are written here. It could be something else that you're like, oh, I have to remember that. But please make sure you write down something that's going to help you understand and remember this particular equation or this particular lesson. And I will see you in class.